Example 7 here is set up to be sort of like a multi-part free response question. Part A, find y prime if x cubed plus y cubed is equal to 6xy. We've got an implicit equation. We've got a y cubed up in there, and we also have the product of x and y over there on the right-hand side. Part B, find an equation of the tangent line to the folium of Descartes, which is what this thing is known as, at the point 3, 3. Okay, that should be pretty easy because part A, we had to find the derivative. We could plug that point into the derivative. We can add the slope, combine it up with the point they already gave us. We can write the equation of that tangent line. Part C, find the point in the first quadrant at which the tangent line to the folium of Descartes is horizontal. Horizontal tangent line, that comes when your slope is 0 from some sort of fraction. For our derivative, that's going to be where the top is equal to 0 and the bottom is not. And when it says in the first quadrant, chances are that there's going to be multiple of them, and we only want the one that's over here, okay? Okay, we're going to need some space to write for sure. So get out some paper, lots of it, maybe a ream, a whole ream of paper. Okay, part A, I'm going to, just for convenience, write this equation down again, because who's going to remember it? That was rhetorical. You didn't have to answer. Okay, so let's find the derivative. That's what we're finding. Okay, so on the left-hand side, taking the derivative of x cubed, we just have 3x squared plus the y needs to be differentiated implicitly, 3y squared dy dx. And then on the right-hand side, sort of like what happened in the last exercise, product rule. Yeah. Okay, so I'm just going to make my two functions look like this. 6x, here, I'll get rid of all that red stuff, that blood. 6x is the first function, and then y is the second function. Or I can just bring that 6 out front and ignore it until the very end, whatever. I'm going to tag it with the x. So the derivative of the first function will be 6 times the second one, y, plus the first function, 6x, times the derivative of the second one, which is just a dy dx. All right, now we're going to have to swap places with some stuff. I'm going to actually make this one a little bit brighter. So here and here, those both need to go on the left-hand side, yes. And then we will get this guy over there to meet the 6y. Okay, all right. And we can do it in multiple steps, or maybe we can do it at one complete step whenever we factor out the dy dx. I'm going to leave that choice up to you. dy dx minus 6x dy dx is equal to 6y minus 3x squared. Okay, and then we have that common factor of dy dx that I'm going to factor out. And notice that it does have more than that. It has a common factor of 3 that I could pull out. I'm going to deal with that here shortly. But right now I'm just going to factor out a dy dx. And I'd have 3y squared minus 6x is equal to the 6y minus 3x squared. I guess I could have dealt with that 3 way back up here. That would have been a smart thing to do. Anyway, now let's divide. dy dx is equal to 6y minus 3x squared over 3y squared minus 6x. Right? Okay. All right. And like I was saying here, let's divide common factor. Everything is divisible by 3. So let's divide everything by 3. And I would get a 2y minus x squared over a y squared minus 2x. All right, then, here's my derivative. That's all the first part asked. Now, to be perfectly honest with you, like on a free response question, an actual free response question on the exam, they usually give you this. They tell you right up front that here's the derivative. And then they just ask you to derive it, to show that the derivative is equal to that. And they do that because they don't want you to mess up the other two parts of the question based on some wrong derivative that you may have gotten implicitly. Okay, but I'm fairly confident about our answer. Not that I have like an answer key right in front of me or something. Okay, so remember now on the second part, we wanted the equation of the tangent line I think it was at 3, 3. Okay, so what two pieces of information do you need in order to find the equation of a tangent line? You need a point, check. And you need a slope. Plug that in there. So I will write it thusly. dy dx such that x comma y is equal to 3 comma 3. And like we've seen in another example, we need to plug in both 3's into the x's and to the y's. 2 times 3 minus 3 squared over 3 squared minus 2 times 3. Okay, we got 6 minus 9 over 9 minus 6. That's just weird. I got a negative 3 over a positive 3. I get a negative 1. Wow, all that work for a negative 1 for our slope. We just found our slope. And now combine it up to get our tangent line right down here. Y minus 3 is equal to negative 1 times x minus 3. There you go. Nothing wrong with leaving that equation in that form, for sure. Sure, you didn't have to write the negative 1. You could write just a negative sign. Can you go ahead and solve that thing for y? Probably. You don't have to. Why risk it? I mean, if it's multiple choice, you may have to. So distribute the negative, x plus 3. Y is equal to negative x plus 6 in equivalent form. And notice that what it said was find an equation. So yeah, point slope form is just fine. All right, finally, C. Find the point in the first quadrant at which the horizontal line, no, the tangent line is horizontal. That's what I'm trying to say. Okay, I'm going to need another page, as you can see. So I'm saying I needed a ream of paper for this one problem. How do I get horizontal tangent lines? The top equaling 0. So I need 2y minus x squared to be equal to 0. y minus x squared is equal to 0. Let me verify that real quick. Okay, there we go. Right? Chances are within the scoring guideline that was worth a point. And here we are again, where we have an equation that has both x's and y's in it. And how am I supposed to solve this? How am I supposed to figure out? Don't I need another equation? This is two variables. I need a second equation in order to solve it. Do I have a second one? We sure do. It's the one they gave us. It's the original equation, right? So once again, I am going to have to solve this for either x or for y and substitute it into the other equation. Which one's going to be easier? To solve for y or to solve for x? If I solve it for x, then I'm going to have to take the square root. I'm going to go ahead and solve for y. So y is equal to x squared over 2. Where's that going to go? That's going to go into the original equation. Take my word for it, that original equation is x cubed plus y cubed is equal to 6xy. So we will take that nonsense and plug it into this nonsense for y. So it's going to go here, and it's going to go there. And then simplify all the other nonsense. X cubed plus x squared over 2 cubed is equal to 6x times x squared over 2. And now we have an equation that's just got one variable in it. Let's simplify it. Squared cube is going to give us x to the 6th over 8, right? You think so? Is equal to, I can take half of that 6, make that thing 3, combine up the x's, I've got 3x to the 3rd. Ooh, that means that I have a common factor here. Or not common factor, I've got like terms. I got like terms, so I can combine those things up if I wanted to. And I'm gonna, because this is essentially a polynomial that I have to solve, I'm going to write the x to the 6th first, since it's larger. Subtract these over, I'm going to have negative 2x to the 3rd is equal to 0. I don't like to have fractions up in my equations. I'm going to get rid of it by multiplying by 8. And I'll have x to the 6th minus 16x to the third is equal to 8 times 0. And now notice that it's very convenient. There's no constant term here, so we can just factor this one pretty easily. We can just pull out an x to the third. X to the third times also x to the third minus 16. There we go. Is equal to 0. Apply that good old zero product property. Maybe x to the third is equal to 0, which means that x is equal to 0. Or maybe x cubed minus 16 equals 0. Add the 16 over. Take the cube root. X is equal to the cube root of 16. I don't know about you, but I got a pretty good feeling about the 0. Let's try it. Okay, how do I try it? Well, I need to plug it back in someplace. All I have is the x. I only have the x coordinate, right? So I need the y coordinate. How do I find the y coordinate? I plug it back into the original equation. So I'd have a 0 cubed plus y cubed. Oh, you know what? I don't have to do that one at all. You know I don't have to do that one? I'm going to tell you as soon as my pen starts working. Not in quadrant 1, right? That's on the axis. That's on the x-axis, so it doesn't even matter if it works or not. We want it strictly in the first quadrant. Okay, all right, so let's come back over here. That positive cube root of 16, it is definitely in the first quadrant. It's a positive number. And, I think I'm going to rewrite this just a little bit. I'm going to rewrite this as like 16. 16 is 2 to the 4th, I think. 2 to the 4th. And then maybe rewrite that as 2 to the 4/3 power. I don't know if that's any prettier or what, but I have to do the same thing that I was gonna do over here that I crossed out. I gotta plug it back into the original equation so I can get its y coordinate. Okay, here we go again. So x quantity cubed, so that's 2 4/3 cubed plus y cubed is equal to 6 times my x coordinate, 2 to the 4/3 power, times y, if I am not mistaken. Yes, I could do that, but why am I doing that? You know what I could do? You know what would be much simpler? I have another equation that relates x and y's. It's the one that I started with. Where the heck is it? It's the one that oh, here it is. Look at this. Y is equal to x squared over 2, or I'll just write that as half, times my x coordinate being squared, which was 2 to the 4/3 power, and then let's square it. Yeah, that's going to be a little bit easier. Right, so let me just back it up here and show you what I just did. So I realized in the process of doing this, of course this was going to make this thing really, really obnoxious, but I had another equation which related our x and our y's together. Right? In a system of equation, you can plug it into any of them and it should give you the exact same number. Okay, all right then. So let's keep going with that. Half, I have to double that one, so 2 to the 8/3. Right, and then think of this as really 2 to the -1 power. 2 to the 8/3. And that -1 is the same thing as -3/3, so I subtract that, that's 2 to the 5/3. All right, what did that just give me? It gave me the y coordinate, the x coordinate was 2 to the 4/3, and the y coordinate was 2 to the 5/3. What do we have going on right here? Well, according to my calculations, that's where you got yourself a horizontal tangent line. Horizontal tangent. But I do need to make a quick verification. That only happens when the top is equal to 0, but the bottom is not equal to 0. Let's just check that real quick. Just real quick. Just bear with me real quick. Let's make sure that the bottom is not also equal to 0. What was the point again? 2 to the 4/3, comma 2 to the 5/3. And let's plug it into the bottom. Let's make sure that that's not equal to 0. So I'll have 2 5/3 squared minus 2 times 2 to the 4/3. Yeah. Okay. And then when I square that first term, it's 2 to the 10/3. And this one, when I do the multiplication, think of that as 3/3. Add those exponents, 2 to the 7/3. Not going to get 0. Hooray. So we have accomplished our task. We did find ourselves a horizontal tangent line in quadrant number 1. Let's take a look at what this graph and stuff looks like just real quick before we call it a day. Here it is. All right, and then here's our tangent line, the 3, 3. And then apparently some sort of place, I guess it's like, it's super, super small. I guess someplace in here, close to the origin, is where we're going to have that horizontal tangent line. Perhaps, I don't know, or maybe it's actually, I think it might actually be like right up there. That looks like where it might be. Yeah. All right, yeah, I'm going to call that one.